Yeah, hi guys, this is Dhruv joining in. So today we are going to begin with the Terraform training, which is the infrastructure as a code, right? So we are going to go through the infrastructure as a code basics, like the architecture of Terraform and all the prerequisites. So all the theoretical concepts which we are going to replicate in the practical lab sessions from tomorrow, maybe day after tomorrow onwards. All those concepts we are going to discuss today. Okay. So yeah, before we begin this session, do you guys have any questions regarding the previous sessions we gone so far? All right. So if there are no questions, so we can get started by sharing the screen. So let me start sharing my screen. All right. So I hope that's visible to you now. Okay. So yes, this is basically cloud DevOps, okay, specific to AWS platform. So we are going to use Terraform to provision the AWS infrastructure services, right? So if you remember, we gone through all these 13 lab work sessions in the AWS training, right? So all of these 13 tasks is somewhat related to the AWS infrastructure. We are creating some kind of services, right? We are configuring some kind of services in each and every task on the AWS platform, right? So all of those configurations on the cloud we did manually with the button clicks can be automated using the Terraform framework. Okay, so to give you a brief intro about Terraform, so this is something a framework which is specific to infrastructure as a code. It is not just limited to AWS. We can also go through GCP, Azure, and other cloud vendors. You can provision the resources using Terraform, the same framework, right? And this is a product of a company called HashiCorp. Okay, so HashiCorp is the owner of this framework. So that's the reason it is called HashiCorp Terraform, right? And it follows a language, like there are programming languages, Python, Node.js, right? The for Node.js people use JavaScript, so TypeScript, Go, Java, right? All of these are programming languages to build software modules. Similarly, for building this infrastructure as a code, since it is going to be some kind of coding, okay, so this coding is going to be done in the HCL language, which is HashiCorp language, coding language, right? So we are going to follow HCL scripting throughout the Terraform training, and the file extension of the Terraform files will be a .tf. Okay, so that is the reason it can be also acronymed as TF. So if we say TF or Terraform, it is one and the same thing, right? So this is a brief about the Terraform framework, which we are going to go through. Any questions or queries?
Hi Dhruv.
Yes.
So it's an application that we have to install in our system.
Yeah, it is also a CLI tool. You have to install Terraform, just like Git.
Okay,
To
okay,
install
okay,
Git, we install AWS CLI
okay,
for AWS CLI operations. Similarly, for Terraform framework, for the Terraform CLI operations via terminal, we have to install Terraform. So I have already installed on my local machine since I am working with this framework since a good time now. So
okay.
on local,
So
I have this specific version on Mac OS.
okay,
Okay. So the same tool can be also installed on Windows, Ubuntu, and other operating systems as well.
okay. So, and you also explained something about, I kind of lost somewhere. You also explained something about um, scripting Java,
Correct.
similar to JavaScript, and you said something. So we
Yeah.
need that scripting for this one, or what is that? I didn't get that
Yes.
exactly.
Yes. So from the name itself, like Terraform is a infrastructure as a code, right? So this is infrastructure which is going to be scripted as a code, right? So that is what IAC stands for, infra as a code. So that means we are going to write some kind of code to automate the provisioning process. For example, if you want to provision a server, you need to go to EC2 instance, right? EC2 service, and then you're gonna fill up the form manually, right? Each and every time you're gonna fill up the details and provide the instance type, the key pair, the region, and all of those values, right? So what if you can have a scripting tool using which you can configure these values just once, and whenever you need to provision, you can just execute the script. So as soon as you execute the script, that infrastructure resource, which is a EC2 server, will get automatically created.
Okay, you mean when you mean script, is it nothing but coding?
Yes, it is kind
Okay,
of a code.
okay,
So,
so
mhm.
coding for this one, do we need to write, or it's already written and we just have to use it?
Yes, so the documentation is already available. We are just needed to refer those documentation.
Okay,
So
okay,
no such code is required from scratch. You can always refer to the existing code base, which I'm
okay,
going to walk through.
okay, okay,
So just literally going through the documentation itself, you can understand. You just need to know what exact configuration you need.
okay,
Okay. So there's a reason I suggested to first of all create that infra manually
okay.
using AWS console. So once you create it manually, you can exactly understand what all configurations you will need. What is the instance type? What is the key pair? What is the region in which you want that EC2, right? What is the
Yeah,
VPC ID? What is the subnet ID? And those kind of things.
yeah,
So all of these properties are nothing but kind of a configurable value, right? It may change from instance to instance. These kind of values may change.
okay,
So that is the reason it is known as configurable values for each and every resource, right? For
okay,
S3 bucket, for EC2 instance, for VPC, right? So all of these configurable values can be scripted in Terraform.
okay,
So if you're going to go with the console approach, it is called manual, right? It is called
okay,
the manual approach. But if you go with Terraform, it is called automation,
okay,
right?
okay,
Because you're gonna write some code. So using that code, you can automatically provision those same resources. Resources will be same whether you go with Terraform or directly from the console. Okay, the end result is going to be the same.
yeah,
But
yeah,
in case of Terraform, the only benefit we are going to get is at scale. So let's say if you are given a task to provision hundreds of EC2 instances for your application need. So you can't literally go each and every time and fill up those forms, right? You need some kind of automation.
yeah, yeah.
That's where Terraform will help you,
Okay, cool.
right? Yeah, so a good question to begin with. I hope this will set the context good enough to go ahead with the next slide. All right. So yeah, this
Extension of Terraform on VS Code.
yes, that is also highly recommended. So guys, this is a VS Code, okay? Just like other software like Postman, MySQL Workbench, and all of those things, right? You can install this VS Code as well on any specific operating system. It doesn't matter. You can install it on Mac OS, Windows, Ubuntu, right? It is easily available. And at this icon, you can see over here at the left hand side, in the middle section, there is something called extensions. So these are nothing but kind of a plugin. So in the browser, you install some kind of plugin for some kind of feature. Okay, so this is kind of a software installation. So you can install this plugin specific to the framework or the language you're working on. For example, if you're working on Python, you can search for Python related plugins and those things, right? So you can install it by clicking on it. You can uninstall or install, right? Similarly, for Terraform as well, there are a few plugins already available. So based on the number of downloads and the rating, you can judge each and every plugin whether you are feeling comfortable with it or not. Okay, you can install them as and when needed. Okay, So these plugins will help us to, automate some of the process, and it will also help us to identify a few things in advance, right? If, for example, if we have some kind of typo mistake or kind of a writing issue, right? Any kind of error while scripting the code, those kind of extensions will help us to highlight those kind of errors before we go ahead and use those code. Okay, so that is the reason for each and every scripting language and tool. For example, if you're using JSON, so you can search for JSON. Okay, similarly for YAML, you can go for YAML specific plugins. So all of these plugins are available. This will definitely make your life easier. If you install those plugins, you can use some kind of intelligence on top of your VS Code, right? So similarly for Terraform as well, you can install it, because of course we're gonna use these this ID specifically VS Code extensively in all the DevOps practices, right? All the lab works from now onwards. Okay, especially when we are beginning the scripting part of it, then we will need some ID. ID is basically interactive development and environment, right? So VS Code is kind of ID where developers and software engineers would like to work. It will make their life easier. Okay, with some of these smart tools over here, we can use some of the suggestions and recommendations coming from those extensions, right? So yes, you can install VS Code, of course, on your base OS and install the extensions as well as per your usage. You can install all of those related to your specific language or scripting tool, right? At least just install Terraform and AWS as well. If you want, you can just go for AWS specific toolkit, a CLI configuration. If you want, you can install those plugins. All right. So going ahead with the architecture. All right.
I got one more question.
Yes.
So, like you have extension on the VS Code, right? So we can any type of integration, like, or like we have just some, like have some kind of like this much you can add it, or like we can do anything on that.
In terms of plugin, like in terms of extension, you asking?
Yes.
No, extension as far as you're working for the
Mm-hmm.
personal usage on your personal system is totally fine. You can install any specific extension. But when you're working into a real-time project into for a specific customer, you need to check with your project manager if you are supposed to install, because there may be some chances, because some of the extensions may have some kind of vulnerability getting into the code, right? So some kind of code leakage may happen.
Yes.
That is the reason all of the extensions are not trusted. Okay, only those approved by the organization should be used. Not all of them are good enough. Okay, we don't know what's going to be used inside the extension, so we never know. But for personal usage, just to
Okay.
explore the features, of course, you can use it to have a good idea about the background activities going on and the benefits of each and every plugin. You can explore these extensions for sure. Just like ChatGPT, because these days people are just going crazy about ChatGPT, but it is not so reliable source. Similarly, these extensions are also something
Mm-hmm.
which you have to choose very wisely, because it may introduce some kind of vulnerability into your code because of some malfunction or some kind of um, intruder activity getting introduced into your code. It may happen. So extension installation is something you have to think twice, especially when you're
So is
working
it
on
safer
those
to like on
projects.
Git?
Yeah, so Git is going to be the source code management tool. Okay, so for source code vulnerability scanning, we have some kind of tools. Okay, so whatever code you're gonna check in into the Git, okay, so all of those code are supposed to be built first and then going to be deployed onto the cloud, right? So build, then deploy. So at the time of building that specific source code, which is
Mm-hmm.
there in your GitHub or maybe some kind of Bitbucket or GitLab, There is some kind of source code vulnerability
Mm-hmm.
scanning happening in the CI process. So we'll go through those kind of processes in the CI/CD pipeline setup. It is a part of the build process
Okay.
where all the vulnerability scanning are happening. So using those kind
Okay.
of tools, we can scan the code, whether it is up to the benchmark or not.
Okay.
So if at all,
Okay.
if any kind of vulnerabilities are present and you have unintentionally pushed those kind of code, then too the CI/CD pipeline will automatically detect those kind of issues in the code. And such code will not be built and released into the cloud. Okay, so this is the standard practices people do follow. If it is not getting followed, then definitely there is a point of concern into your specific project, right? Because this is something
Okay.
needs to be
Mm-hmm.
highlighted.
Okay.
Okay, fine. Because especially when we talk about production grade environment, this is the basic check marks which has to be fulfilled, and then we can go with the production release. With the lower environments like a non-prod and
Got it.
it is still fine, but when you go with the higher environment, this is something very, very necessary. Okay, fine.
Mm-hmm.
Any other questions before we go ahead? All right, fine. And let's begin the session with the Terraform architecture now. All right. So basically, we will be somewhere sitting over here, right? So as a DevOps engineer, we will be responsible to provide the Terraform solutions because this is part of infra. Okay. And we are going to be part of the infrastructure team. You can also call it as a platform team, right? Because on top of your platform, which is a cloud infrastructure, all the application code will be deployed, right? Infrastructure is a very basic need for each and every project. And that's where taking care of your infra and automating those infrastructure provisioning process is very, very important. Okay. And that's where Terraform is going to help us to automate those processes, right? So we will be somewhere over here. We can consider our local machine or kind of EC2 instance like a server, which is set up specifically for the infrastructure provisioning processes or operations. You can also set up these infrastructure provisioning processes into a CI/CD pipeline, right? We will also go through one of the pipeline scenario or specifically for Terraform, how we can automate the infrastructure provisioning process along with Terraform as well as pipeline. So end-to-end automation can be achieved. We'll go through those kind of automation very soon. Okay, but at the moment we are just going to focus on the infrastructure part, how to provision the infrastructure resources like EC2 instance, S3 bucket, VPC, glue jobs, and all of those things, SNS, SQS, right? So we will need some kind of scripting, right? In case of Terraform. That's where the Terraform configuration files comes into picture. So as a DevOps engineer, we will be scripting these Terraform config files, which is having the extension of .tf. Okay, so all the Terraform scripts will have extension .tf. Okay, any questions?
Yeah, hi Dhruv. I have one question.
Mhm.
You said the DevOps team will be scripting those. So DevOps team is going to script this, or we are just going to use the script that has been already made?
Yeah, so as I told, like we will refer some of the documents, but we need to prepare our own version of the scripts specifically into this Terraform script because all of the Terraform script is part of the infra,
Okay.
right? Because these Terraform scripts will be used to automate the infrastructure provisioning process rather than creating manually from the console, right?
Okay.
So
But the
we are
script is given to us by, it is automatically given to us by Terraform only, right?
some of the documentations are provided by Terraform. Okay, I'll
Yeah.
go through the process. By referring those documents, we can prepare our own version, but we have to prepare our own version because see, in your project, your infrastructure will be different. In my project, infra will be different, right? So first of
Okay.
all, understanding what is your specific needs of each and every project
Okay.
infrastructure. By understanding those needs, we will prepare own custom version of the Terraform scripts.
Okay, so we are using the script to create the architecture.
Correct, exactly right.
Okay, okay.
Perfect. Because that's what we are going to achieve. So in every project, we are going to have some kind of a cloud architecture, right? Like EC2 instances, S3 bucket, Lambda functions, DynamoDB, and whatnot, right? So all of those designs will be provided by solution architect, right? But in order to deploy those kind of resources onto the cloud, we can't create each and every services manually for all the environments, for dev, for QA, for test, right? For staging. Let's say, for example, your project has 5 environments. Okay, you can't simply go ahead and create all the 5 environments manually. You need some kind of automation. So it's okay if you create the environment manually, first of all, in the test environment to understand how exactly your infra will be configured. Okay,
Okay.
once you understand the cloud configurations, once you understand the steps, the step-wise process, like first create EC2, then create and the Lambda function, then create S3 bucket, and so on. Once you have the process flow understanding of your infrastructure needs, then you can automate the same process into Terraform.
Okay.
Okay, so step one would be, of course, you should create the infrastructure manually into a test or kind of a POC environment, a kind of a sandbox environment, right? A test environment. And then you can try to replicate the same set of configurations into another environment using Terraform. Because in the previous environment, you will be already going through those steps. So now you will have understanding exactly what are the steps, what are the set of steps to be followed. So that is the main reason why I insist everybody to go through the manual process, at least for the test environment, so that you can get an understanding what are the cloud configurations and steps involved, because there are some dependencies on each and every resource, right? You also need to interact with the dev team. What are the application needs? So by understanding the application needs, then after infrastructure needs, as per the solution architect, right? By gathering all of these details together, then you can compile all the informations and then you can create the exact replica of the infrastructure into a test environment first manually. Okay, then you can document all the steps, step 1, step 2, step 3, step 4, and so on. Once you have the stepwise process, you will exactly know from where to start and what all the configurations are required. So once we have those stepwise details available in a document like a Word file or maybe text file, then you can think of automating the same steps using Terraform. Because Terraform will do nothing, it will just help you to automate the same process. It will not do a magical thing, right? It is no magic. It is all kind of the same configurations which you're gonna do manually. So to have a strong understanding exactly what the configurations are is a must prerequisite. Okay, so again, I repeat again, you have to configure your whole infrastructure first manually into a test environment, and then you can document the steps, what all steps are required, and then you can think of automating all the steps into Terraform script. As easy as that, right? Right. So that's why the Terraform configuration file, which is nothing but the .tf file, will be used to script all those steps which we documented. Okay. So we will be playing around over this area. Okay. Our work will be only limited up to this box. Okay. We will be having a team of DevOps or maybe cloud or a infrastructure engineers team, right? And all of them will be contributing into some kind of Git repository to add the Terraform files, because you alone will not be responsible for creating the set of Terraform scripts, right? You will be working on specific task, the other guy will be working on the other task for the same infrastructure need. So as a team, you will collaborate together and prepare the infrastructure team, and all the infrastructure codes will be checked in into a GitHub repo. Okay, so once you have all the tested Terraform files, then you can go through the Terraform operations. So these are all the Terraform supported operations. Okay, all of these operations are managed by Terraform itself. Okay, it is just a set of instructions which we need to provide to the Terraform. As per the instructions provided, it will operate all the process to configure the resources, to provision the resources, right? To delete, if you want to delete the resource, that too you can delete the resource. If you want to update the resource, for example, as of now you set the key pair as key pair 1.pem, right? Tomorrow you want to change the key pair, then also the same configuration data changes can be accommodated into Terraform script. You can also change those configurations tomorrow. So all of this kind of dynamic needs can be adjusted into the Terraform script itself. So that you have to no more go into AWS console and do those steps manually. You just need to focus on the Terraform script. Okay, just take care of the Terraform script, perform the Terraform operations, and check the Terraform logs. If everything looks good, that's it, you're done. Right? You don't need to manually go into the console and then change those configurations, click those buttons, right? Because today you are having just one environment. Tomorrow you will be having 5 to 10 environments. And changing the same configurations into multiple environments is a headache, right? That too manually. But if you have a set of config files like a Terraform framework where you can just change those values, those configurable values, then it will be much easier to get hold of those changes. You can control your infrastructure directly using the config files. So all the configuration related changes can be updated, can be deleted, can be added, or you can also remove those configuration changes, right? So all of those kind of permutation and possibilities are totally applicable when you have the Terraform framework. Okay, and down the line Terraform is also going to use some kind of authentication, right? For example, if you're working on AWS cloud, you can also use Terraform to provision the resources into Azure cloud, maybe Google cloud, maybe some kind of digital ocean cloud, right? IBM cloud. Okay, Oracle is one of them, right? So Terraform is supported for all the platforms. Okay, provide support for all the platforms, out of which as of now we are specifically concerned into AWS platform, right? Since we are going through AWS training series and we have already completed 13 tasks out of it, right? So after going through all of these 13 tasks, now we will go through a few sessions, specifically into the fourth one. Okay, so we are going to go through this task to automate the same process. Remember, we created VPC, then public and private subnets in the task number 4, right? And these same steps are documented into the document, into the PDF as well, which I shared into the group. So the same manual steps can be automated using Terraform, right? So we'll go through this set of process and operations to create a VPC first of all, and then create public, private subnets to configure those route tables, right? You also need to add internet gateways. You need to manage your security groups, right? So all of those configuration onto the cloud platform will be managed using Terraform scripts, which is nothing but a .tf file.
So, Dhruv, just a quick question.
Mm-hmm.
So, all those things we did manually on AWS console. So, now
Yes,
we are going to perform them through Terraform and
correct.
that will be automated, right?
That's right.
Okay.
That's right. Okay. So in case of console, guys, we were supposed to have some kind of credential like your email, password, MFA, those things, right? So you might be wondering how would Terraform be authenticating those process? Is there any AWS username password involved, right? So the answer is it is simply following AWS CLI configuration. Once you have your AWS CLI configured using access key and secret key region values, okay, you're gonna have some kind of profile. Let me walk you through it again. So see, if I do a AWS configure on my local, since I already have installed AWS CLI, okay, it will ask me an access key, secret key, region, and the output format, out of which these three, which is the first three values, are very, very important. So using these AWS CLI configurations to get the authentication part working, Terraform will also reuse the same profile. So by default, if you don't provide any profile values over here at the end after the AWS command, for example, if you want to create a specific profile, okay, configure hyphen profile, then I would say test, today is 11 July, right? 11 July, okay. So by providing this command input, which is AWS configure hyphen profile, then after my profile name, okay, this configuration will create a profile which will be named as test 11 July. So I will be actually creating a profile with the name test 11 July. Similarly, if you want to create your own version of profile, you can create it by providing these details, which is access key, secret key, and region. Okay, and you already know how to prepare this access key, secret key from the AWS IAM service, right? Okay. If you still have any questions, I can share the document to create and generate those access key, secret key from IAM. The preferable access key, secret key of that IAM user will be having admin access, so that you won't be facing any kind of access related issues. If you have admin access, then that user's access key, secret key will not face any kind of difficulty in terms of access, right? So we suggest to use admin access user and generate access key, secret key of that user from the AWS console. Okay. So
Can you share that documentation, please, when you're done?
yep, sure.
Thank you.
Even I can just simply walk you through that process. It is really very, very simple. Okay. So since you just asked the question, it is very simple process. You can just hover to your IAM service. Okay, go to users, this part which is IAM user. Okay, you want to create a new user, that too with an admin level access. So for example, if I'm creating a new user by clicking on the add button, let's say test admin user, because I'm going to create admin user level access, right? So this is provide user access to AWS management console. No. Why? Because this user is going to be created for AWS CLI purpose, not for console purpose, right? Console is this dashboard, but this user we are creating specifically for this CLI purpose, right? That's the reason we are not going to check mark this checkbox. Let's click on next one. Look at this user already exists, so let's say -1. Okay, so add user to group, add. Okay, yeah, we can go to the third option, which is attach policies directly. Okay, and you can search for admin for the permissions. So the very first access you're gonna get over here is gonna be administrator access. You can just check mark this one. That's it, it's done. You can go to the next step. Okay, you can attach your tags, environment, and the purpose. It's just the test environment, and the purpose you can say it is what, just for demo, right? That's it. So once you create this user, just go to that user, go to security credentials. Okay, here is the access key section where you can click on the create access key button, and of course this is for CLI, right? For AWS CLI. So you can select this radio button over here, and you need to click on this checkbox for the prompt purposes. So next you can just add a descriptive statement over here and create your access key. That's it. You can also always download these details into a CSV file. So if suppose if you forget this the secret key value, you won't get it back from the console. So even if you even if you don't remember, and of course it will be very, very random code, so nobody can remember unless it's a supercomputer kind of thing, right? So you can download these details into CSV and store it somewhere into a credential manager onto your local machine, right? So if tomorrow if you want to reuse the same user access key secret key, you can simply go to this CSV file, open it up, okay, and here you're gonna have your access key secret key. So the same set of access key secret key, you can use it over here. So let's say I'm copying it down and pasting over here to create a test profile for today's date, and this is my secret key, okay. The region, let's say US East 1, okay. So this profile, which is named as test 11 July, is now configured because we already provided the access key secret key value as per the details we got in the CSV file, right? And if you want to check those entries, you can always get into the file which is /, which is the root location of your system on Ubuntu or Mac OS. Then go to .aws folder. Inside AWS, because this is going to be AWS CLI configuration, right? And we are going to just check whether this profile exists or not, okay. So we are going to go through credentials file first, okay. So here we can see there is a lot of profile. Simply search it down. We can perform a grep operation, of course. So July, right? So here it is, okay. It is at the bottom. So you can see the profile name which we provided in the argument as a parameter at the end is configured as a profile name over here along with the access key secret key. Similarly, the region related value, you can see it is just having access key secret key. It is not having any kind of region value we provided over here, right? So that detail will be available in the config file. So config, okay. So here it is. You see, profile is test 11 July, and it is having the region US East 1, which we configured a few seconds ago. Okay, so once you are done with this profile setting on your machine, then you can think of starting up with the Terraform operations, because Terraform will need some kind of authentication, right, with the cloud provider. Specifically into AWS, it is going to be via AWS CLI. Okay, so in the Terraform, we are going to provide this profile value, same value, the same profile value which we just configured, right? Any questions?
Yeah, Dhruv. So
Mhm.
in order to install Terraform into terminal, first we need to configure it with the AWS CLI. That's what you're trying to say?
No, Terraform installation is a separate story. You can install it
Okay.
independently, but
Okay.
in order to utilize Terraform framework, this is going to be a prerequisite.
Okay.
Okay, once you install, and then if you decide to start using the Terraform framework, that's where you're gonna provision some kind of resources using Terraform, right? And Terraform will try to authenticate to your cloud provider, which is AWS in this case. So let's say in the console, you're gonna provide your username, password, and MFA code, right?
Yeah.
But now we are talking about CLI, Terraform CLI. Okay, so how will Terraform CLI authenticate with your cloud provider, which is AWS, using this AWS CLI configuration? You see, so Terraform will not use any kind of username, password, or any kind of a MFA code. It will use AWS CLI configuration.
Okay. So for now, you haven't installed Terraform yet. So in order to configure a Terraform to AWS, I mean cloud. So this is the prerequisite. What you did now is.
Yes, for Terraform installation, I told you before as well, it is totally independent. You can
Yeah.
install
Yeah.
Terraform, but when you want to start using the Terraform to provision the resources, that's where some kind of authentication will be needed, right? Some kind of
Okay.
authentication like username, password. So those authentication will be made using AWS CLI. So when you decide to start using the framework to start performing Terraform operations after installation, then you will need this setup, which is AWS CLI setup. Okay, so I would suggest everyone to configure a specific profile name. Okay, you can use this command which is hyphen profile, then for your profile name at the end, right? So the same command, but just with the addition of the profile value. The reason is we can use the same profile name while configuring the Terraform resources. When we go through the Terraform lab work, we will use this kind of profile names. Okay, so that is the reason, because what happens is different environments will have different profiles, because there is a chance where you can have n number of environment. For example, dev, QA, and production. Okay, three environment, and it may be possible that all the three environments are in separate accounts, are in three separate accounts, because the thing is people try to segregate these resources from account to account. So there are high chances that in the production level the account is totally different. That's where you're going to have a separate account, and that's why you have to create a separate AWS user from IEM, right, to create this CLI. Okay, so for each and every environment we're going to have a separate AWS profile configured. So for test, for QA, for staging, for production, each and every environment is going to have a separate AWS profile. So using this profile parameter, we can configure those profile values. The profile name is something optional. You can keep it as per your choice, right? But the values which is going to be asked after this command has to be exactly same as per the CSV file you downloaded, right? So AK, SK, and the region has to be perfect. Otherwise, this configuration won't work. Okay. So this is one of the scenario where we will be using AWS CLI for Terraform authentication. Okay. So this is one of the key concept in Terraform to
Hey,
perform the
Drew, I
yes.
kind of get confused where it said during configuration, the you see when you put AWS config,
Mm-hmm.
this you said the name that is going to come after your name needs to be the same with the name on the AWS that was used.
Yeah.
During
So this
the
profile is separate. The profile name is you can keep it as per your choice, but the
Mhm.
values which is asked like access key, secret key,
Okay,
and
okay,
region has to be from this CSV file which you downloaded.
okay, okay. I understood. Thank you.
Okay. Fine. Yeah. So that was the intention about it. Any other questions? All right. If you don't have any questions, we can go ahead with the architecture principles. So we learn about the config files. We learn about the CLI configuration, which is required for the Terraform authentication, especially when we will be working on AWS cloud, right? So AWS CLI configuration will be needed as a prerequisite to work with the Terraform operations. You can install Terraform independently, but when you decide to start using those Terraform operations, that's where the prerequisites will come into the picture. And the prerequisite for Terraform operations is specifically for AWS cloud is going to be AWS CLI configuration, right? So step 1, install AWS CLI. Step 2, install Terraform. Step 3, configure your AWS CLI with the profile, right? That profile should be specifically used only for Terraform. Okay, so don't reuse the same profile so that you don't get confused. So only use that profile for Terraform operations and nothing else, right? Keep it separate. And then you can just go through the Terraform operations, which we are going to explore very soon. So these are the cloud providers, as we discussed, the various kind of cloud vendors out there in the market, out of which Terraform is something most widely used cloud platform. Okay, and over here there is one more component which we haven't explored yet. Okay, the Terraform core is also one of them. So Terraform core is nothing but the framework, the set of libraries. Okay, so there is one kind of Terraform CLI operation which is called Terraform init, INIT init. So init stands for initialization. Okay, so when we initialize the Terraform libraries at the very first step, the Terraform core will be created. So Terraform core is nothing but the set of libraries which Terraform will download automatically as per the configurations which we specify in the TF file. So for example, if we create a TF file for EC2 instance, then it will only download EC2 instance specific libraries. If we create a TF file for S3 bucket, okay, then the Terraform will only download those S3 bucket specific libraries. So as per the configurations which we specify in the TF file, the Terraform is going to prepare the core library part of it. Right? So it totally depends upon the architecture, what exactly you want to implement. So as per the architecture, you will prepare the Terraform scripts, and as per the Terraform scripts, Terraform core will be built. Okay, because unnecessary no extra libraries or no extra data will be downloaded. Okay, only those libraries and only those data Terraform will automatically download once you execute Terraform init, which is actually required for those Terraform configuration files. Okay, so Terraform core will be totally dependent upon the type of resources you're gonna provision on the Terraform configuration files. And in case of TF state, okay, TF state, which is the state file, also popularly known as state file. So this state file is very important. Okay, this is like kind of a heart of Terraform architecture. Okay, this is the core part. Actually, this is very important. If you lose this state file, then the whole infrastructure will be orphaned. Okay, if you lose this Terraform state file, the Terraform framework will not understand the cloud configurations which you provide via Terraform file. Okay, so this state file is very important, very important part of the overall environment, whether it is dev, test, QA, or whatever environment it is. So it will store all the state related details. For example, let us take an example. Okay. Okay, finally we are down here. Terraform state file. Okay, so this is nothing but a file. For example, for the Terraform configuration, the Terraform configuration file extension is .tf. Similarly, for Terraform state file, it is .tf state file. Okay, the extension is .tf state. So it will be something like Terraform.tf state. So this file into your project directory will be very important. The reason is all the infra data, all the current infrastructure data will be stored in this TF state file. Okay, it is also known as TF state file, or you can call it as the Terraform state file because it is extension as TF state. Okay, so this file has all the infrastructure data. So for example, you created one TF file, like for example ec2.tf. Okay, into this configuration you specified, in this config file you specified all the properties for your EC2 instance, like instance type, which we use to select T2 micro, then the key pair, then the VPC ID, right, subnet ID, then security group, etc, right? So all of these kind of configurations we were providing into the console as well. Same set of configuration we are going to provide using the TF file. Okay, same set of configuration, but in form of a config file. In the console we are submitting a form which we have to fill up every time when we need a EC2 instance. But now since we are talking about Terraform, into the TF file, which is the config file, okay, using which we can provision those resources, we are going to provide all those properties in form of .tf file. Okay, so we are going to follow a specific format and a specific structure as per Terraform scripting language, which is HCL file. Okay, So HCL is the scripting language as we discussed previously. Okay, scripting language for Terraform. So using this HCL scripting language, we are going to prepare a Terraform script, a Terraform config file. For example, for provisioning, for creating a EC2 instance, by providing all the properties like is the instance type, VPC ID, subnet ID, security group, and all of the same configuration which we used to provide from the console, right? So once we have this Terraform script ready, okay, this is going to be step 1. Then we are going to execute this TF script. So after executing this TF script, the respective infra will be provisioned or created, whatever you say, right? Okay, all of the as per the config files, as per the properties we provide in this file, which is ec2.tf. Okay, so whatever the configuration values we provide in the ec2.tf file, for example, all of these configurable properties, as per those configurations, Terraform will provision the or create the EC2 instance once we execute that TF script. Okay, so what is the process to execute the TF script? We will understand it later. Okay, but while executing this TF script, which is nothing but the same set of properties which we used to provide in the AWS console, okay, then we are going to have the EC2 instance created into the console. Actually going to create it into the console. So these are the two simple steps, right? Two basic steps to work with in Terraform framework, right? So in this second step, Terraform maintains a state file, which is known as Terraform state file, which will be created only after executing the TF script. So once you execute your Terraform script, okay, in the step number 2, Terraform will automatically create this Terraform state file. Okay, we are not managing the state file. Terraform itself will be managing and creating this Terraform state file, and also the data inside this file will be managed by Terraform itself. Okay, we are just concerned with the TF script. In this script, we are just going to configure the properties and all the values we want for all of this configuration into the TF file. As per the TF file, Terraform will read all of those properties and create the resources. Okay. Once Terraform create those resources, in order to maintain a kind of state, a kind of a data, okay, what is the instance ID, what is the VPC ID this EC2 instance used, what is the security ID this EC2 instance was using. So all of those kind of details will be present in the Terraform state file. Okay. So Terraform state file is nothing but the same file which will be creating only after executing the Terraform script. So when your infrastructure actually gonna be created into the cloud, then you will have this state file, and it will have all the details about the infrastructure provision. Okay, so let's say tomorrow, okay, tomorrow you come in and change some configs in the EC2.tf file. Okay, let's say you changed the security group ID. Okay, you replace the security group ID with something else. Previously it was something like this. Okay, and now you change it to something like this. Okay, so this config change, you see over here, this config change regarding security group is also going to be noted into the Terraform state file. So if you change the values into the security group into this file, which is the same file you use to prepare your Terraform script, right, for all the infrastructure resources. In this case, we are just considering EC2 instance as of now. But in the real-time projects, there will be multiple such Terraform files, like for S3 bucket, one for VPC, one for subnets, and all of those things, right? Whichever it is part of your architecture diagram, you're gonna create all of those resources using Terraform files, right? So even if you change any configuration into the Terraform script, all of those configurable changes are also going to be reflected into your Terraform state file, right? So the Terraform state file is gonna be exact same replica of the data which is there in the current cloud infra. So for example, in the existing cloud infra, you created EC2 instance, its ID is 123. Then the same instance ID, which is 123, will be available in the state file as well. Okay, so all of the resources created via Terraform, all of the resources data will be managed in the Terraform state file. And if you lose this file, then Terraform will not be able to link those resources which were created by Terraform. You see? So Terraform state file is the key file over here. This is the database. You can say kind of a database system for Terraform. Terraform will always look for two things, which is the TF configuration you specify over here versus the data present in the Terraform state file. So it is actually going to compare two values. If the instance type in the existing TF is T2 micro, and if the same value is found in the TF state file, it means there are no changes. But tomorrow, if you change your instance type to T3 medium, okay, and the TF state file still has the previous value, which is T2 micro, then Terraform will automatically come to know, yes, previously it was T2 micro, now you are changing to T3 medium. So using those two comparable values, Terraform will actually deploy, identify those changes, and then deploy those changes into the cloud environment, right? That is the reason why Terraform state file is very, very important. If you lose this file, if you end up having a corrupted version of this state file, then all the infrastructure resources you created via Terraform will be orphaned, will be lost in the cloud, right? So that is the reason we are going to take care specifically for this state file, and we are also going to have some kind of backup mechanism as well. We are going to back up the state files at regular interval of time. So even if we lose the Terraform state file, or even if we end up having a corrupted version on the state file, still we can have some kind of backup on the cloud for the state file, right? So any questions in terms of state file? Because understanding the importance of state file, what it is, when it will be created, okay, what kind of data will be stored inside this state file is very, very important. Everyone should have clear understanding what is a state file, why it is so important, what data is stored inside the TF state file, and when it will be created, and how the TF state file will impact our infrastructure provisioning process, right? So all of these questions should be clearly understandable into your mind now. If you have any questions, you can ask.
So what I understood when it comes to state file is just is like a replica, right? Where we have to save all our.
No, we don't have to save anything. Terraform will automatically manage the state file.
Okay.
We should exactly know what the data it is inside the state file, why it is so important.
Like an audit trail database, something like that.
Yes, it is kind of a database for Terraform because all the changes you deploy in the cloud, for example, if you configure a TF file for all these properties like instance type, your key pair, and all of these things, right? So all of the property values will be there in TF. So once you execute this TF, which is your Terraform config file, Terraform will automatically create this state file. Okay, and that EC2 instance, which is created by Terraform, will be all the details regarding that EC2 instance which is created by Terraform, all those details will be stored in the state file.
So whenever you execute a new EC2 machine or execute separately, a new Terraform state will be
No,
formed
no, the
or
same state file will be updated.
updated. It's like audit trail of
Audit trail.
your
Correct.
metadata. Okay.
It's kind of, you can say, Excel sheet. So the data inside Terraform state file will look like a JSON file,
Okay.
right? So this is a JSON file, right? You can see JSON file. So the structure inside this state file will be similar to this one. You see, key value, this is the key, this is the value, this is the key, this is the values, right? So for example, instance ID. So it will have some kind of instance, EC2 instance, then here it will be ID value. Similar to that structure, it will create this Terraform state file by itself. We are not going to create it. We are just going to execute the Terraform scripts. So at the moment when we execute the Terraform scripts, as per those execution processes which is taken care by Terraform, Terraform will update its state automatically. Okay, and we can also list down the data inside this state file using a command. We will go to the command. We can also explore the data which is stored inside this Terraform state file. So if in any scenario, if you want to list down the data stored inside the state file, that too in a safe way without touching the file, because the data inside it is very, very important. If you end up having a corrupted version, then all the existing resources which is created by this Terraform state file will be lost, right? So to access this state file in a safe way, it is very, very important, right? And we'll go through the best practices, how to access the state file, how to list all of the resources which is present in the state file. We will go through those operations very soon, okay? But at least you should know what is state file, when it will get impacted, when it will get updated, whenever you perform any Terraform operations, okay? If there are any changes in the configurations, for example, as of now in the state file, it is having T2 micro, okay? And you are changing your TF file because your manager told that now we need to change the EC2 instance to T3 medium, okay? So as soon as you update that value to T3 medium, which was previously T2 micro, okay, then those configuration changes will be compared. So Terraform will actually compare these two things, your TF script and your TF state file. So previously, if the instance type was T2 micro, which was recorded into the state file, which is your database, okay, and now since you change it as T3 medium into the TF state file, into the TF script, so Terraform will identify a change in the configuration, right? So comparing these two files, Terraform will exactly identify whether it is a change to be deployed, or if it is the same value. If it is the same value, T2 micro matched exactly same from your Terraform script as well as from the TF state file, it means there are no changes. But if the configuration changes in the TF state file, okay, then Terraform will easily identify those configuration changes by comparing those values from your TF script versus state file. And after deploying those changes, it is again going to update that state file. So next time when you do another change, Terraform will already know, right? Will be already aware of the existing updated changes, right? So this is how Terraform will work internally.
So do we have to run a command to update those files, or how does it
Yes, yes, yeah. So as at the same time, when we execute the Terraform script, it means we are updating the state file. Okay, so as soon as we execute those Terraform scripts which we created to deploy a specific resource like EC2 instance, okay, at the time we execute the Terraform script, it will automatically update the state file because it is Terraform managed file. It is an internal file managed by Terraform itself. But to understand what is the Terraform state file, okay, again, it is very, very important and why it is so critical for each and every project. Okay? This is what you should know. Any questions or any queries? All right. So if we are done with the existing architecture diagram, then the rest of the things will fall in place. Okay, we will be exploring the same sort of activities from tomorrow and onwards. So this is a very, very basic understanding, guys, right? So with this understanding, we will proceed with the next steps tomorrow onwards. Okay, but if you have any questions, you can just feel free to ask it now.
Hello.
Yes.
In which kind of situation we need to go through df state files?
Yeah, that's a really good question. So let's say if you look at the Terraform plan, okay, so what is the Terraform plan? So Terraform plan is something which will be involved in this execution of the Terraform script operation. Okay, when you execute the Terraform script, you will be given some kind of plan. Okay, so Terraform will provide you a kind of a rough sketch of kind of a rough work. Okay, like if you did any changes in the configuration, then it will provide you a plan that this is what it is detected by Terraform. This is what the changes are scanned by Terraform in form of a plan. So by looking at the plan logs into the CLI, into the terminal itself, you will be given some kind of logs, right? So those logs, you can read those Terraform plan logs, and looking at the logs, you can understand whether those plan is as per your expectation or not. If those plan is not as per your expectation, that's where you need to dig into Terraform state file and check whether there is something wrong with the state file or not. Right?
Okay.
While executing the state file, sorry, the Terraform script file, you will, if you are not satisfied with the plan, which is kind of a log into the Terraform operation, right? If you're not satisfied with the plan, under those scenarios, you can go through the Terraform state file. We will go through the process how to list the data which is present inside state file securely without harming it, right? So this is one of the scenario. Otherwise, you can simply also list down the state file data to get a high level understanding, like what are all the resources deployed by the Terraform. Okay, because all the resources deployed by Terraform will be recorded into this file, which is a kind of database for Terraform, right? So it will be in a JSON format, kind of a JSON file, as I said, right? So also to list down all the resources which is provisioned by Terraform, you can have a look at the state file.
So by looking at the state file, we can also, get the image of infrastructure as well,
Correct,
right?
correct, exactly.
To imagine what is the infrastructure of our project and what kind of
Yes,
services are
yes, you
used.
don't need to go to console, but directly having a high level, a high level overview of the Terraform state file, you can easily understand what you have deployed till now on the cloud. You will get all the IDs, you will get all the data. For example, instance ID, security group ID, subnet ID, VPC ID, all of those things.
Yeah, so in case if like a solution architect want to give any kind of solution, then they can go through the state file and can provide a solution according to the architecture.
Yeah, if at all in any case, because there is going to be a CLI command to list down all of the resources into the stateful, right? So you can also perform a grep operation along with that, just like this one, right? You can also perform a grep operation like your Terraform command to list down the resources. Then after you can grep. For example, if you're looking for specific instance ID or security group ID, whether it is created by your Terraform or not, right? So you can also use this kind of grab tool to filter those data.
In
Okay.
troubleshooting cases.
Yeah, correct, exactly. So these kind of suggestions will be always useful into real-time scenarios when you want to troubleshoot, when you want to debug some of the issues, or you want to help your dev team to get all the information they need.
Okay. Thank you.
All right. Right. Yes, any other questions? All right. So that's it pretty much from today's session. We have just covered a high level intro about the architecture and just couple of slides. Okay, we discussed a lot about Terraform statefile today, and I hope you guys should emphasize more and more on this understanding. Please remember it forever, okay, because Terraform is going to be used in almost all the sessions from now onwards. Okay, so to understand statefile, what is the steps we're gonna perform, all these basic details. Okay, what is the TF file, what is the TF state file, okay, how are we going to configure, what is the stepwise process, so what is core, what is state file, what are providers, what is our role as a DevOps engineer into the Terraform framework to configure the files, and from where Terraform will manage the resources. So all of these questions should be clear out into your mind so that we can go through the next steps of the session, right? So with that note, if you have still any questions open in your mind, you can always feel free to ping me. Okay. And from there we can get into a call, we can get some kind of support, right? And I will share you the document as well as soon as we are done with the initial practical work on Terraform. So from there you can revise the notes and go through the revision sessions as well to practice it. All right, so with that note, let's conclude today's session and we'll catch up tomorrow.